Hi and welcome to this on maths prediction for the OCR Paper 3 Foundation Tier Maths GCSE. Enjoy! Hi, I'm Chris Gilpin and welcome to this prediction for the Paper 3 Maths paper. I hope Paper 1 and 2 have gone well for you. And I'm not going to talk too much, but don't forget that these papers are on our website, onmaths.com, which I'm sure the link will come up there now. If you click on the link, it will take you to the prediction on our website. Don't forget that the prediction on our website changes the numbers in the questions, so you can do it as many times as you want, and you're not just getting the same answers each time. This video will go through all of the answers to a set of numbers. So if you don't understand a question, come to this video and you can see how to do it for maybe a different set of numbers, but you can get the methods. If you check out our website, we've got tutorials for everything. We've got topic busters, demon questions, practice papers, all sorts of things. So please check out our website on maths.com. If you enjoy this video, please click like. If you want to see any other stuff from us, especially over the next few days, please click subscribe. Thank you and enjoy the video. So in this question we're given a train timetable and we've got 4 towns. We've got Ashcook, Flute, Risetown and Colib, and the bus is obviously starting at Ashcook and then finishing at Colib, passing through these towns as it goes. So it says that we arrive at 2017 at Ashcook. Now we will have missed this train and we'll have missed this train, but we'll be in time for this train, so we'll take the 2032 train. Now that will stop at Flute at 2052, but we're looking to see how quick we can get to Risetown, which is the next stop there. We'll get to Risetown 21:24. So for this question, you just kind of got to imagine what the shape will look like when it's finished. And the thing that's stopping it from looking perfect is not having this square here. And let's just check it has 4 lines of symmetry when I put that in. So we've got one there, we've got one across here, then we have a diagonal one here, and then we've got another diagonal one here. So it has 4 lines of symmetry. So for this question we're asked to find the percentage of the shape that's shaded. So there are 4 sections in total and 2 of them are shaded. So as a fraction that would be 2/4. Well, we can halve top and bottom, so it's a half. And you can see there that half of that's shaded. So what is half as a percentage? Well, a whole as a percentage is 100%. So a half as a percentage is 50%. And if you didn't know that, you need to just practice knowing the main percentages. A tenth is 10%, a hundredth is 1%, and a quarter is 25%. Okay, the next question says what fraction is shaded. So we need to know 2 things. First of all, how many squares are shaded. So 1, 2, 3. So it'd be 3 over the total amount of squares. So there's 1, 2, 3, 4, 5, 6, 7, 8 squares. So the fraction is 3/8. For the next question, it says shade in a fifth of this shape. Well, there's 10 squares altogether, and we want to shade a fifth. So we need to find a fifth of 10. In other words, what's a fifth times 10? When you times something by a fraction, just divide it by the bottom of the fraction. So another way of writing that is 10 divided by 5, which is 2. A different way of thinking about this question is if you cut this shape up into 5 equal sections, those sections, the green sections, become a fifth. So if we want to shade 1/5, we just want to shade in one of those sections. And actually that's the amount of squares that our calculation just worked out. So it should be 2 squares. Now, it doesn't have to be the 2 squares that I've shaded. As long as you've shaded in 2 squares, then you've answered the question. And the last question says, write down the fractions there that are equivalent to a quarter. Well, a nice easy way of starting this question off is just write down things that are equivalent to a quarter. So what I'm going to do is I'm going to times top and bottom of this fraction by 2. So 2 over 8. So I've times them by 2. Then I'm going to times them by 3. So it would be 3 over 12. Then I'm going to times them both by 4, and I'm just looking at this original fraction here. I'm going to times them both by 4, so it would be 4 over 16. Then times them both by 5, 5 over 20. Now all those fractions are equivalent, which means the same as a quarter. So let's have a look at our list. Well, we've got 2 over 8 there, so it's that one. And we've got 5 over 20 there. So my answer is going to be fraction B and fraction C. The first thing to look at with a pictogram, which this is the key. Now the key tells us what each picture represents. So if you have a look at the key here, it says each circle represents 8 DVDs. Now that's the complete circle. So it says, what day are the most DVDs sold? Monday, Tuesday or Wednesday? Well, or you can always just look at which has the most shapes. Now Tuesday has 2, Wednesday has 1.5, but Monday has over 2, 2 3/4. So it's definitely going to be Monday, because it's got the most circles. Now, how many DVDs were sold on Tuesday? Well, if each circle represents 8, there's 8 there and there's 8 there. So we just need to add the 8s together, which makes 16. So 16 DVDs were sold on Tuesday. It says how many DVDs were sold on Monday? Well, you've got the 8 there and you've got the 8 there. Now we've got a bit of a problem here because it's not a complete 8. So we need to figure out how much each quarter is worth. Well, what do you times by 4 to get to 8? Well, 2. Let's check to see if that works. So we've got 2 there, 2 there, 2 there, and an extra 2, which is actually missing on that one, would make 8. So that would work perfectly. So to find out a quarter of it, we just divide it by 4, which gives us 2. So we've got the 8s, because we've got 2 complete circles, and then we've got those 3 2s, so we've got another 6. So we just need to add on 6 to the 16. So 16 plus 6 is going to be 22. So that's going to be 22. Okay, let's have a look at the next question. On Thursday, 20 DVDs were sold. Show this information on a pictogram. So let's have a think how many circles that will be. So if I've put one circle down, that's 8. Well, we've still got enough left over. If I put another full circle down, that's 16. Now 16, let's try another one. Let's put another full circle down, and that gives us 24. So that would be too much. So we're going to have to go into those quarters. So we've got 16. How many more 2s do we need? So 16, that would give us 18, and that would give us 20. So we need 2 whole circles and then 2 quarters. So if I shade in, if I draw, then shade in 2 whole circles, and then we've got 2 quarters left over, which is just a half. Let's just check that. What's half of 8? That would be 4. And what's 8 plus 8 plus 4? That gives us 20. So we know the answer is correct. So we're given a basic formula to work out how long this turkey is going to take to cook. It says that the cooking time, so we can just call that time, is the weight, which it says is a 3 kilogram turkey, and just check that the units are the same, which they are. So it's the 3 times 30, then add 90. 3 times 30 is 90, and 90 plus 90 is 180. Now just double check that it wants it in minutes. Sometimes it'll ask for it in hours. Well, it says it wants it in minutes, so 180. When we're asked to write a number in figures, it just means as numbers. So we've got 5,026. We need a 0 there as a placeholder. So you're just going to write 5026, 5026. Next question says, write down the value of 8. Now, if we remember, and let's just write the number a little bit bigger. This is our units column. This is our tenths column. And this is our hundredths column. So the value of the 8 is 8 hundredths. We can write that as a fraction, 8 hundredths. And that's the answer. Question C, write down 655 correct to the nearest 10. Okay, so 655, if we just do a quick number line, 655, the next 10 up is 660. And the next one down is 650. So those are the two it can round to. This 655 is bang on halfway, and if they are halfway, they round upwards. So the answer is 660. I draw that properly. If it was any less, if it was 654, it would round down. So if the last number, if that number there is 5 or more, it will round up. On this scale on the side of the jug, we're not given the little tiny notches. So the word estimate means that we're not going to get it exactly right maybe, but we're roughly going to be correct. Now there are wrong answers to this. So if I wrote the answer 22, which would be down here somewhere, that's clearly wrong because we know that the water is above 30. We know the water's between 30 and 40. And if you have a look, it's less than halfway. So we're expecting a number that's below 35. I think if you wrote the number 35, you would get that wrong because it's clearly less than halfway. I think the numbers, probably to get it right, you might get away with 34, but definitely 33 or 32. I think, personally, it's closer to 33, but some of you might look at that and think it's closer to 32, and chances are we'll both get the marks. With stem and leaves, the tens, and sometimes the units, but mainly the tens, are in this column, and then the units go in this bit here. So, first of all, I'm going to pick the smallest number, and it's easier to do this by doing it smallest to biggest, because the units here must be in order of size. Now the order goes, the smallest go on the left hand side, and the biggest on the right hand side. However, if you're doing a stem leaf over here, the biggest go on the right hand side, sorry, the smallest go on the right hand side and the biggest go on the left hand side. Basically the smallest must be as close to the middle and the biggest must be away from the middle. Okay, so the smallest one we've got is 30, so we're going to do 30 first. Now we've got the 3 already, so we're just going to put a 0 there, and that represents 30. Then the next smallest I think is 33. So the 3 goes there. I think the next smallest is 39, so the 9 goes there. Okay, and that's the 30s done, so let's move on to 40s. 41 goes there, 43 goes there, 44, 48. And the last few, so 52 and 52, well they're the same, so they can be next to each other, and 64. So the smallest go on the left, and then you get bigger as you go to the right, and that's really important because you need to do that to get the right marks, or to get the correct answer. Okay, the last thing to do is the key. Now the key is just pick a value, any value. I always pick the one at the top left, but it can be any value. It doesn't even have to be a value on there. And you do 3 line 0, which I've just copied the bit I've done in the yellow, means 30. Now you might ask, why do we need that? Because it's always going to be 30. Well, not quite, because you can get ones that are 4 line 1 means 4.1, which is why these ones here aren't always going to be tens. Sometimes those will be units and you'll be writing down the decimals. So just look out for that. Now you need to have, first of all the numbers in the stem and leaf, secondly them in order, and thirdly the key. That's what the mark scheme is going to say. The easiest way to order decimals is just to put yourself a few columns down the page, and hopefully I'm going to try and get enough columns. I always end up with not enough, so if I put some extra ones in, that should suffice. And just literally put the numbers in, so 14.828, and make sure the decimal points are lined up. So 8.60 is going to be like this, and I'm going to put an extra 0 in to make them all the same length. It doesn't change the number at all. So 14.86, I'm going to put 0 in there, 14.820, and then 14.7. Now we're starting with the smallest, so I'm looking for the smallest one first. Well, the smallest one's leaping out because if I just look at this column, there's only one number that has a 0 there, all the rest of them have 1. So the 8.60, and I have to put the 0 because that's how it's said in the question, is definitely the smallest. So we can cross that out. That's definitely the smallest. All the other ones are tied. They're all 1 in that column. So we move over to the left, the next column, sorry, the next one to the right. So 4, 4, 4, 4, they're all tied. So I keep moving along. Okay, there's a clear loser in this one. There's a clear one that's the smallest in this one. The bottom one, 14.7. So that's definitely the next smallest. So I can cross that one out. All the other 3 have tied because they're all 8. So I move on to the next column. Now, looking at this, there's 2 2s and a 6. Now that 6 is definitely the biggest number. So I could fill that in as the biggest number. And we've just got to work out what the smaller of these remaining 2 are. Well, let's move on a column. And you can see here that 14.82 is the smallest or smaller of the 2. And so that leaves the 14.828 in that position. Now always just double check the 5 numbers you've listed are the same as in the question. That's the same. 18.60, that's the same. 14.86, that's the same. 14.82 is the same, and 14.7 is the same. You sometimes lose a mark if you haven't written exactly the same number. Same goes for when there's fractions and decimals. You've got to write down the number that it showed in the question. Alright, so the first place to start on this is to plot the points. So point A is at -3, -2. So along the corridor and up the stairs, well, we're going across -3 on the x-axis, which is this one here, and then we're going to go down 2 on the y-axis. So it's this one here. A really common mistake is to muddle them up. So as long as you remember you're going across and then up or down, obviously if it's negative you go down, then you should be fine. Now it says point A, so I probably should label that as A. And point B is 0, 3. It means we're not going left or right at all. We're just going to stay at 0, but we could go up 3. So it's going to be there. And point C is at 3, -2. So along 3, down 2. Which could be that one there. So that's point C. And it says plot and join these coordinates. So I'm just going to get my ruler and plot and join them. Well, we've plotted them, so we're just going to join them. And there we go, makes a nice little shape there. Now question B says what type of triangle is ABC? So looking at it, it looks like this length here and this length here are exactly the same length. So when we've got a triangle with 2 sides the same length, it's an isosceles triangle. And try and learn the spelling of isosceles, because it does look better when you spell it right. I remember it's ISOSCELES. The SOS is like a Morse code thing to to get help, save our souls. So I've always remembered SOS, as in, oh my goodness, I don't know how to spell isosceles. Okay, so this question gives you a little bit more of a hint of how to answer it than your exam will. And to answer this question, we're going to find the price per tissue in each box. So the first box is £8.07, but we know we're going to work out our answers in pence. So I'm just going to do 807. And to work out the price per tissue, I'm going to divide that by the amount of tissues. So divide it by 24. So 807 divided by 24, and that is 33.625, so that would be 3 to 2 decimal places, which it asks us to do in the question. The next one, again, I'm going to do the pennies divided by 20, so 683 divided by 20, and this time it works out to 2 decimal places. Don't need to do anything, don't need to round it. And the last one is 623 divided by 15. So 623 divided by 15, and I do have to round this one because it's 41.5 and then 3 recurring, so it's just going to be 3. Okay, the last bit of the question is to work out which one is best value for money. Well, on 24 box they cost £33.63. Sorry, 33.63 pence. Oh, let's try that fourth time. 33.63 pence. For 20 boxes, they cost 34.15 pence each, and 15 tissue box is 41.53 pence each. So the 24 tissue box, or the 24 box, is the cheapest, or is the best value. And in your answer in the exam, you just explain that it's the cheapest price per tissue. Make sure that you know the names of the parts of the circles. So a diameter is a line that just goes across a circle going through the centre. If it doesn't go through the centre but it goes across the circle, it's a chord. A bit of a circumference is the whole way around the circle. A bit of a circumference is called an arc. And there's a few more parts of a circle you need to know. Now, on this question, there's a line which touches the circle just at one point, and it's a straight line. The name for that is tangent. To answer this question, first of all, we need to know what the gradient is. So what you do is you pick 2 points that you know the coordinates of, which is that one and that one I'm going to pick. Works with any of them. And we work out how much up and how much across it's gone. Well, it's gone 1 up. But I'm going to do this in pence, so I'm going to say it's gone 100 pence up, and it's gone 10 miles across. So to work out the gradient, we're going to do the change in y, so how much it's gone up, over how much it's gone across. Now, some students have that the wrong way around because coordinates work the other way around. You go along the corridor and up the stairs. With gradients, how far you go up or down over how much you've gone right. So that's going to be 10. Now, it says give an interpretation, so we haven't finished answering the question. What does that mean? Well, it means for every 1 mile that we've gone, it's going to cost 10 pence. Now remember, I converted this into pence, so instead of in pounds, it's going to be pence. So the gradient is the cost per mile, and I'm going to put in brackets 10p. Now it could be that just writing the cost per mile for this question would give you the mark, but if you actually wrote the gradient as well, then you definitely get the mark, and sometimes it will ask you for the gradient and then ask you to interpret it. When you're asked to do a plan or a front or side elevation, it's important to remember that the diagram you're going to be drawing must be absolutely square on. So there's not going to be any 3D lines at all. It's just going to be 2D shapes like rectangles. Sometimes you have triangles. Occasionally you might get a circle or a semicircle. So let's have a think. What does plan mean? Plan means view from the top. So what of this shape are we going to see from the top? Well, we're definitely going to see this one. But we'll also see this one as well. Now we've got to work out what the sizes of them are going to be. Well, the top one's easy, it's just 7 centimeters by 6 centimeters. Now I'm not going to be able to draw this accurately because I don't have a ruler, but we can almost get it right. We can get it kind of right. And if I label it, that's going to be 7 centimeters, and that should be 6 centimeters. And in your exam, just make sure you actually measure them, because they are said to you in here, and it does say accurately construct. So you want to make sure that it's done 7 centimeters and 6 centimeters. Now, the difficulty is going to be the last bit. Well, we know it's going to be 6 across because it's the same as this one here. But what's the width going to be? What's this one going to be here? Well, if this one here is 7 and this one here is 9, what's left over? Well, there's 2 centimeters left over. So it's going to be 2 centimeters in width. Ooh. Let's use this one, right. So it's going to be 2 centimeters in width. So 2 centimeters there. And this one obviously is going to be 6 centimeters, the same as the right hand one. Now this line we have in the middle, this line here, is really important because that shows that there's a join, that there's something happening there. So you need to construct, you need to show that, especially if there's a change in elevation, just show it with a line on the diagram. Question A seems like a really complicated question, but it really isn't. If you think about what you know about a rectangle, you know that opposite sides of a rectangle are equal. So if you just write down x plus 1 is the same as 12, and then solve it. So what we're going to do is we're going to take away 1 both sides. Then x equals 11. So we know that x is 11. Let's check that out. It says here x minus 1. Well, what is 11 take away 1? Well, it's 10. And that is the same as that. So we know that x equals 11. And that's it. Question B. Have a think about what you know. You know that all angles in a triangle add up to 180. So we know that if we add y, 2y, and 3y together, it's going to equal 180 degrees. So again, let's just get our lines down so that we can solve it. So 1y plus 2y plus 3y, well, that gives us 6y in total. And then what we need to do is get rid of that times 6 there by dividing 6 both sides. So y equals 180 divided by 6. Well, I know 18 divided by 6 is 3, so I know that's going to be 30. Okay, so for this question we're asked to construct a pie chart from the table. We've got a number of frequencies. Now the first thing to do is work out how many frequencies we've got in total. So first calculation I'll make is adding up all the frequencies, and that calculator tells me is 24. Okay, now the problem we have is a circle has to add up to 360. And at the moment all of our frequencies add up to 24. So we've got to find out what we're going to multiply all these frequencies by to get them to add up to 360. We do that really simply by doing the calculation 360 divided by whatever the total of the frequencies are. So 360 divided by 24 on the calculator equals 15. So this 15 here, if we multiply all three of our numbers by 15, we will get the amount of degrees we need each colour to be. So I'm going to add an extra column here and say angle. And I'm going to do 14 times 15. And it's 210 degrees. 7 times 15 is 105 degrees. And 3 times 15 is 45 degrees. And let's just check this. Let's add them up. 210 plus 105 plus 45 equals 360. And then you need to plot it onto the pie chart. Now, I don't have a protractor on this, so I can't physically do it. And to be honest, it's much more helpful to physically print this out, do it on a piece of paper, and get someone to help you use the protractor if you're not 100% sure. That 210, for instance, what I would do is probably draw a straight line down here, like a mini sort of working out line, and do 210 take away 180, which is 30, and do sort of 30 extra degrees, which is going to roughly be there. And don't forget to label them, so that would be red. 105 is just over 90, and I'm just doing this roughly. I'm not even going to use a straight line to show that it's not accurate. And then label that blue, and then check that you've got 45 left over, and hopefully you do, and then label that other. Okay, so this is quite a tricky question because it mixes fractions and ratios together, but we've got to be comfortable with that. So I'd first of all just show the information so that I can get my head around it. So we've got Denver, who as a fraction has 3/19 of the food. And so that leaves how much? Well, we've got a calculator, so we could just do 1 take away 3/19 on the calculator, but we know that that's going to be 16/19. So we can kind of ignore Denver now because we used Denver's amount, or fraction of the food, to work out Engels and Fido's combined. So that's how much food they'll get, but they're sharing it in the ratio of 5:2. So in total, the amount of parts they have is 5 plus 2, which is 7. So there's 7 parts altogether. Okay, and each part, so one part, is going to be worth, well, as a fraction, it's 16/19 divided by 7. So 16/19 on the calculator divided by 7, which gives us 16/133. So that's the fraction of each part. Now it says, show what is Fido's share. So we're looking for Fido's share. Now Fido gets 2 lots of that. So looking for Fido, he gets 2 lots of that fraction. So I'm going to times that by 2 on the calculator, which is 32/133. Now it does say show your answer as a percentage rounded to the nearest percent. So to work between fractions and percentages, I just need to times by 100. So what I can do is just times that by 100. I'll do it on the calculator, times by 100, and press S to D if it comes up as a fraction. And it says 24.060 blah blah blah. So to the nearest percent, Fido gets 24%. With two-way tables, we've got to use the totals to work out the missing numbers. So a nice place to start is this box here. If we have a look, we've got a total of 46 people with brown eyes. 23 of them are female. So all we need to do is 46 and take away the 23, and that leaves 23 left over. Now let's have a look at a nice easy one. Right, green eyes, that's a nice easy one there. We've got 48 in total, and 27 females with green eyes. So we want to do 48, take away 27, and that leaves us with 21. Now if we have a look at this one, we have 23 females 23 males with brown eyes, 18 males with blue eyes, and 21 males with green eyes. And we assume that there weren't any others because they're not in the table. So we add those together and that gives us 62 in total. And let's have a look at this one maybe. So we've got 62 females altogether, and we've got 27 of them have green eyes and 23 of them have brown eyes. So we take the 23 and the 27 away from 62, and that leaves us with 12. And we can just check that. We can do 23 plus 12 plus 27, and it equals 62. So we know that's right. With that one sorted, we can get this one. And if there's 18 males with blue eyes and 12 females with blue eyes, that means there's going to be 30 altogether. Now this total is either the total of these ones or the total of these ones, and they should give you the same number. Don't add the blue and the green ones together, so it's only one of them. So 46 plus 30 plus 48 is 124. And let's just check that. 62 plus 62 is also 124. So don't ever write down 248 because that's not correct. So in total there are 124 people whose eye colour were checked. Okay, so here we're given a trapezium, and we know it's a trapezium because it's got two sets of parallel sides and it's four-sided, well, one pair of parallel sides. And the formula for a trapezium is we look at both of the bases, which are these ones here. These are the bases. We know they're the bases because they're the ones on the parallel sides, and we add them together to halve it, and then times by the height. Now the height hits both of the bases at 90 degrees, so this is our height here. So it's going to be half times 3.4 plus 1.5, and we're going to times it by the height, which is labelled as x. Now we know that the area, in fact let's remove that, because we know that the area is 4.165. So I'm just going to tidy up the left hand side a little bit. So I'm going to do 0.5 times brackets 3.4 plus 1.5, and let's work out what that is. And that is 2.45 times x, or just x, equals 4.165, and we just solve the equation. So we're going to divide both sides by the coefficient of the x, the number before the x, which is 2.45, so we just get x on its own. So we're going to be left with x on the left hand side, and I'm going to do 4.165 divided by 2.45, and we get the answer of 1.7. Now I can go back and check that that works, so I'm going to do 0.5 times brackets 3.4 plus 1.5 close brackets times 1.7, and I get the answer of 4.165, so I know it's correct. Okay, so this question's about exchange rates, and this part here is quite important. If I just rewrite that to make it a bit bigger, this is basically saying that to get from pounds to dollars, we just need to times by 1.42. And you can get that by just dividing the right hand side by the left hand side. Now 1.42 divided by 1 is just 1.42. So the problem with this question though is that it wants the answer in pounds, so we'll need to convert both of these things into pounds. So we're actually going the other way. When we go the other way, instead of times, we just divide. So we're dividing both sides, or we're dividing dollars by 1.42 to get to pounds. So we've got $3,000, and we want to convert it into pounds. So we're going to divide it by 1.42, and I'm just going to type that into my calculator. So 3,000 divided by 1.42, and it's to the nearest pound 2112.6, and we'll round to 8, obviously to 2 decimal places, because money is always to 2 decimal places. So it says also that that the laptop costs £2,500 in the UK, and how much cheaper is the laptop in the USA than the UK. So what we need to do now is we need to do £2,500, which is the price of the laptop in the UK. We're going to take away the £1,112.68, and on my calculator I'm just going to type in 2,500 take away answer, and then press equals, and it gives me the answer of 387.32. So it's £387.32 cheaper. Okay, so to draw this graph, we're going to use our table of values, which is shown below. So when x equals 2, what I want to type into my calculator is 2 squared minus 2 plus 10. And it's exactly the same as the equation at the top, but instead of x, it's going to be 2. Now I can do this in my head. 2 squared is 4, 4 take away 2 is 2, and 2 plus 10 is 12. We're going to do this for the other ones, so when x equals 1, we'll do 1 squared take away 1 plus 10. 1 squared is 1, so 1 take away 1 is 0, plus 10 is 10. Then when x is 0, just going to be 0 squared take away 0 plus 10, which is obviously going to be 10. Now when x is negative 1, we've got to be careful. If you type this into your calculator, make sure you put any negatives in brackets, otherwise it will get that wrong. So minus 1 squared is 1, and if you don't put into brackets, the calculator will assume that it's minus 1, because it will square the 1 first and then put a minus before it. Minus minus makes a plus, so that's going to be 12. And when x is negative 2, it's going to be negative 2 squared minus negative 2 plus 10, which is 4 plus 2 plus 10. 4 plus 2 is 6, plus 10 is 16. Okay, let's plot this onto our graph. So it's 16, was it 12? 10, 10, and 12. Okay, so next we need to join these up. Now there's a few rules for joining up a quadratic. It needs to be a U rather than a V. If you've got 2 points at the bottom, which we do, you need to make a point to go beneath them at the bottom of the curve, and it's got to be one line rather than feathering or a couple of lines, or oops, I've made a mistake, so I'll do it again. Okay, so I'm going to try my best here to join these up. I'm not fantastic at this, but should be alright. Now be careful here to go beneath those 2 points. Now up like that, and that should be fine. So it's this part here, you've just got to make a point to go beneath those 2 points. If you draw a line straight across, you will lose a mark. Okay, so this question is a little bit more complicated than it first seems. So we've got Adrian, Ben, and Charlie, and they share some sweets in the ratio of 6 to 3 to 8. And it says that Charlie got 12 more sweets than Adrian. Well, first of all, let's have a look and see how many more parts that Charlie... Ooh. Always cross my L's for some reason. Charlie got more than Adrian. Okay, so he got 8 take away 6 is 2. So he got 2 more parts. And so let's have a look and see what one part is worth. So those 2 parts equates to 12 more sweets. So we do 12 divided by 2, 6. So each part is worth 6 sweets. And it says work out the total amount of sweets. So we need to work out how many parts there are in total. So we do 6 plus 3 plus 8. Now I know 6 plus 8 is 14, plus 3 is 17. So we've got 17 parts in total. Each of them is worth 6 sweets. So to work out the amount of sweets, we do 17 times 6. Now we could do 7 times 6, which is 42, 10 times 6, which is 60. So add the 2 together, it's 102. So there are 102 sweets altogether. Okay, so we're asked to write 88 as a product of its prime factors. So the first thing to do is write 88, and then we have 2 shoots coming from it. Now I need to find out which two numbers times together to make 88. Now a little tip, if you've got an even number, always pick 2. So 2 times 44. And whenever we get to a prime number, we always circle it, because that's finished. So 44, we can get another 2 out of that, we'll divide another 2 out of that, so 2 and 22, 2 and 11. Now 11 is also a prime number, and when you're left with just prime numbers, then you write your answer out like this. Now if you're also asked to write it in index form, that means instead of 2 times 2 times 2, you're going to write 2 to the power of 3 times 11. Now don't work that out, because that will give you 88. So 2 cubed times 11 is 88. These questions are just based on a few rules of indices. The first rule says that if you've got two powers with the same base, which these two do because they're both a, you add the powers. Now if you think about it, a squared is a times a to the power of 6 is a times a times a times a times a times a. So in total we're timesing a by itself 8 times. So it's 8a to the power of 8. The next rule says if you've got a power inside the bracket and outside the bracket, you times them together. So it's m to the power of 3 times 6, which is m to the power of 18. Now this last one's a little bit more complicated, and I'm going to write it out so I've got a larger one to play with. Okay, first thing I focus on is the number. Now 55 over 11, so I know that 55 divided by 11 is going to be 5. 55 divided by 11, that's all we've got to do. And the reason we can do that is there's only one term at the top and one term at the bottom. A term is defined by, whether there's a plus or a minus, and there's no pluses or minuses here. Okay, so next one, we've got the r's that we want to divide. So we've got r at the top and an r at the bottom. Now this r at the top is technically r to the power of 1. Now when we do r to the power of 1 divided by r to the power of 8, which I'm going to write out down here so I can show you, you take away the powers. So when you times them, you add the powers. When you divide, you take away the powers. So that's r to the power of minus 7. Okay, now we're left with the s's. And it's the same thing with the s's. This time we're doing s to the power of 15 divided by s to the power of 8. So it's going to be s to the power of 15 take away 8, which is 7. So my answer would be 5 r to the power of minus 7 s to the power of 7. Okay, so we're given a regular polygon, so that's going to be quite an important word there. Regular means that all of the sides, angles and exterior angles in this polygon are exactly the same. So if I added another one here, this would also be x. If I put another exterior angle here, all the way around this, they're all x. They're all the same, and there's 16 of them in total. Now the one thing we know about exterior angles is they always add up to 360. So to find out what that angle is, we just get 360 and we divide it by 16, because there's 16 identical exterior angles. So I get my calculator out. 360 divided by 16 equals, and it's 22.5. So we can check that. We can do 22.5 times 16, and it has to add up to 360, which it does. Right, so you'll need a calculator for this question. The different calculators do things slightly different, but by far the most common calculator, and if you haven't got one, I would recommend them, are the Casio calculators. Mine has a shiny solar panel on the top, but you don't need that. The average battery life lasts way longer than you'll ever need the calculator. So the first button I would press, and there's different ways of doing this question, is the button to get the fraction, which on the Casios looks like this. and that will make a fraction appear on your calculator. Now, some of the older ones, the fraction looks a bit weird. It involves like a symbol like this, and actually on the new ones it can, but you need to change the settings if it does that. It should open up, it should look something like this, like a box and then another box, and there should be a cursor blinking in this box. Okay, so we want to fill in this top box first since it's already flashing. So 76.8 plus 81.9. Okay, and so to shift downwards on the Casio calculators, there's a sort of cursor, like a cursor stick, a direction button thing. It's the big blue button beneath the screen on most of the calculators, and you just push the down to go to the denominator of the fraction. And then we need to fill in this bit here, so 0.19, and then to get the squared button, it's on like that. So you just press that, and it looks exactly as it does in the question on the screen, so you know you've got it right. So you press the equals, and my one comes up with 4396.121884. Now, it might be tempting to try and round that, but it says it wants all the figures, so just put them all in. Now, if your calculator is set to a mode which it's going to show even more numbers, then normally six digits after the decimal point is more than enough. They won't require you to go to 100 or 200 decimal places. On this question, that's actually an exact amount. Okay, so write down correct to two significant figures. Now, to do two significant figures, we start counting at the start of the number. So I'm going to do a red line where you need to start counting. And you just count 1, 2 numbers. So the blue line is where I've stopped counting. Now, all of these numbers here are going to be reset to 0. They're going to go away. Well, not quite. Let's come to that later. Now, this number here, the 9, is what we call a decider number. Now, that number is going to go. That 9 is gone. Okay? But before it goes, we need to see whether that is 5 or more or 4 or less. If it's 5 or more, it pushes that 3 up to a 4. So the answer will be 4, 4, and then you'd think, oh, okay, that's it, rounded, and you'd write that in your answer column. But when I said they disappear, they don't quite disappear. All the numbers above the green line that I've just drawn reset to 0. They turn to 0. Now, if you think about it, if I don't know what would have a decimal place, but if you have a number 4,396.121884 written down, and someone says, "Can you tell me roughly how much that is?" Then if you say the answer of 44, that's not roughly 44. It's nowhere near 44. So the 9 and the 6 will turn to 0. And actually the other numbers do too. But these numbers here are not changing the number at all. These 2 zeros here will make that 4,400 instead of just 44. The other numbers after decimal point, we might as well get rid of them. So the answer is 4,400. Okay, because we don't need to show these numbers. Now, the reason students make this mistake is they're so used to decimal places. Now, decimal places, you always remove them because they're always after the decimal point. But with significant figures, they need to turn to zeros. So, inequalities, what are they? They just mean instead of x equaling something, x is greater than or smaller than something. So, x can normally have lots of different values. Now, this statement here is really important. Integer just means a whole number. So we know that x can't be a half, because that's not a whole number. Now, x says here, x is greater than -7 and is less than or equal to 3. So when it asks you to write down all the numbers that that's true for, well, let's have a think. Well, if it's if it's greater than -7, then it can't be -7. It can't be equal to it. So it's going to be -6, -5, -4, -3, -2, -1, 0, 1, and 2. Now let's have a look at the other one. It says x can be less than or equal to 3. So that line there, if you look at it, that little line there, so if I do it a little bit bigger, the line that I've just drawn there says it can be 3. So we must include 3 in our answer. And that's how you get full marks. Now you probably will get 1 mark if you forget to put the 3 down or you put the -7 accidentally. Right, the next one I'm just going to write out a little bit bigger. Now the way we do this question is the same way as solving just a normal equation with an equals, but don't ever put an equals. There was an exam a few years ago that if you wrote an equals in it, they would give you 0 marks. So the first step is to expand the brackets. So I do smiles and rainbows, but if you've got another method, that's fine. I'll put a little line there to remind me to times it. So 5 times 3x is 15x. And 5 times -5 is -25. Now you could have divided both sides by 5 and that would have been fine. Next step is to get rid of this -25, and you must start with that. You can't get rid of the 15 first. So we're going to add 25 to both sides to get rid of that -25. So we're left with 15x on this side, and 35 plus 25 will be, well, 5 plus 35 is 40, 40 plus 20 is 60. Now to get rid of this times 15, we need to divide both sides by 15. So that will get rid of the 15 there. And how many 15s in 60? Well, 2 times 15 is 30, so it would be 4. Now be really careful not to accidentally put any equal signs in your answer, and especially this bit here. So it's x is greater than 4. So there's a lot of places to start with this question. Whenever I'm given a shape in a question like this, I always ask myself, well, do I need to work out the perimeter of it or the area? And sometimes you're going to have to figure out something else, but it's mainly going to be those two things. Well, this is all about covering the floor, so I'm imagining I'll need to work out the area. So I'm going to start off working out the area. Now to do that, I've got to work out what shape it is. Well, it's a trapezium because there's 2 parallel sides and it's 4-sided. So if you've got a pair of parallel sides and it's 4-sided, it's a trapezium. So to work out the area, the formula is half a plus b h. Now you need to work out what h and a and b are. A and b are always the ones on the parallel sides. So it's those two. It doesn't matter which way round you call them. H is always the one that connects the two at right angles. So half 2.5 plus 1.5 times 11.5. So I can get my calculator out and I can do 0.5 times brackets 2.5 plus 1.5 close brackets times 11.5. And that gives me the answer of 23. So the area of this is 23 meters squared. Okay, so I've managed to work that out. Let's have a look. So tiles are sold in packs, 25% off marked price, and they're marked at £12. So next thing we can work out is how much they actually cost. And it doesn't matter if you do this in a different order, as long as you do each step and label it well. So cost of pack. Okay, so we've got £12 and we need to reduce it by 25%. Okay, so first of all I need to work out 25% of £12. So the way I can do that is just find a quarter of 12, so divide it by 4, so that's going to be £3. So the cost is going to be £12, take away my £3 discount, which is going to be £9. So the cost of the pack is £9. Okay, so it feels like we're getting somewhere. Now, if each one costs £9, but each one covers 2 meters squared. Okay, so we know we've got 23 meters squared to cover. So what I can do is I can work out how many packs I need. So packs needed. So I've got 23 meters squared to cover, and each pack covers 2. So I'll do 23 divided by 2. Now that gives me the answer of 11.5. So I need 11.5 packs. Well, unfortunately, shops don't like you taking half a pack. Trust me, I've tried. They really don't like it. So you must always round this up. Otherwise you won't have enough. If you round it down, say if it came out as 11.4, if you rounded that down, you won't have enough. So there'll be a patch of untiled floor in your kitchen. That's not good. So the answer is going to be 12. So I need 12 packs. So total price. So I need 12 packs, and each of them costs £9. So 12 times 9 is £108. So it's going to cost £108. Now, the last bit of the question, she says she's got £100 to spend. How much extra? So it wants it in pence as well. My goodness. So we need to do extra. And all I'm doing here is doing 108, take away 100, which equals £8, which is 800 pence. Okay, to convert from standard form, you just write the number down, and this here, the power, will tell you where to go. So if the power is positive, then you go to the right. If it's negative, then you jump to the left. Now since it's negative, we're going to jump to the left, and it's -6, so we're going to jump 6 spaces. So 1, 2, 3, 4, 5, and 6. So the decimal point will now be here, and you fill in all of the jumps with zeros. So one of the jumps is used by the 8, but all the other ones we fill in with zeros. And whenever you've got just a decimal point, you need to have something before it, so we put a 0 before it. So the answer will be 0.00000084. That would be the answer. So let's just count. There's 5 zeros and 5 zeros. Okay, to convert to standard form, you write out the number, and you try and put a decimal place in to make the number between 1 and 10, but not including 10. So if I put it in here, that would be 72, so that would not be right. So I need to put it in here. Then you count how many times you had to move the decimal point to get it there. So the decimal point started at the end of the number, and we had to move it 1, 2, 3, 4, 5, 6. Okay, so the rule is that the number has to be between 1 and 10, which this one is. Now, if you had a big number, then the power of 10 will be positive. Now here we did have a big number, so it's going to be positive 6. On the previous one, we had a small number, 0.00084. I don't know if I said the amount of noughts that were there, and you can see that the power in the question was negative. So negative power of 10 is really small number, positive power of 10, really big number. This does turn up on the calculator paper as well. So if it does, you can actually just type in question A into your calculator and just write down the number it gives you. Now some calculators are smart and do things in standard form, so you might need to do it this method anyway. Whenever we see a 3D shape in a question, you've got to ask yourself, is the question asking for a volume or a surface area? And that should be the first question that goes into your mind. Yes, it might be asking for something else, but those are the main two. We're looking at this, we're filling the swimming pool with water, so it's going to be a volume question. Now, way of approaching this is figure out what the shape is. Well, the shape is a trapezium-based prism. So we've got to first of all work out what the area of the trapezium is. So I'm going to draw the trapezium out first. And that height is going to be 2.7 that side, 5.3 that side, and 25 across. And I'll leave off meters because I know they're all in meters. But do check they are all in meters when you do this. So we've got to first of all work out the area. Now the area of a trapezium is half A plus B H. Now A and B are always the two parallel sides, and then the height is the one that connects them at right angles. So the height is going to be 25 there. And all you're doing is working out the average of the two bases, the 2.7 and the 5.3. We're going to times that by 25. Okay, so we'll crack our calculator out. 2.7. Some of you will probably see this straight away. So the first bit comes out as 4 because halfway between 2.7 and 5.3 is 4, and then times 25 is going to be 100. So the area is 100 meters squared. Now for a prism, so volume, all you need to do is work out the area of the cross section, which is this bit here, the bit we just worked out, and then times it by how 3D it is. I think they call that the length officially, 15 meters. So the volume is going to be 100 meters squared times 15, which is going to be 1,500 meters cubed. So that's what the volume is, and it says the machine transports the water at a rate of 20 meters cubed per minute. So in 1 minute it's going to be 20, in 2 minutes 40. The other way of working this out, or the other way of thinking about this, is how many 20s are there in 1,500? So we can say time equals, so this is how much it's got to fill, and this is how much it does per minute. So on the calculator, 1,500 divided by 20, which equals 75 minutes. So it's going to take 75 minutes to fill the pool. Okay, so this question is asking us to find unknown lengths. Now, the easiest way of approaching this question is to draw the two triangles, the little one and the big one, separately. So I'm going to do that really quickly. I'm going to draw the small one, and I'm going to draw the big one. There we go. And I'm going to fill in the length. So this small one has 37 here, and 17 at the bottom here. This big one has 50 down the side and 34 at the bottom. Okay, now a second most important thing to realise with this question is that these two triangles are mathematically similar. The reason is that the top angle here is shared. These two here are both corresponding because they're off a parallel line, and it's the same with these two. And any two triangles that have exactly the same angles will always be similar, which means that one's an enlargement of the other. And with enlargements, we're always thinking about scale factors. So we've got to find out what you times 17 by to get to 34. So on my calculator, I do 34 divided by 17. I probably shouldn't need to do it on the calculator, because obviously the answer is 2. So if I'm timesing that side by 2, and I'm looking for length AD. Now AD is this one here. How do I get from 37 to AD? And remember, it's corresponding side, so it would be the left hand side will go to the left hand side. So I'll times that by 2. So it would be 37 times 2, which is going to be 74. So my answer will be 74. And the last one, let's do it in a different colour. Now we're looking for length CE. So CE is a bit of a weird one, isn't it? Because CE is this bit here. So all I need to do is work out what AC is, which is this one here. So let's work out what AC is. So to go from the big one to the small one, instead of timesing by the scale factor, I'm going to divide. So I'm going to divide it by 2. So AC is 25. Now if AC is 25 and the whole thing is 50, so let's try and make this a bit clearer. So the whole thing is 50 and AC is 25, so this bit up until this bit, then CE must be 25 as well, because it's 50 take away 25, which is 25. Okay, so to find the volume of a cone, we obviously need the formula. So the formula is a third pi r squared h. Now the r is the radius of the circle at the bottom, the h is the height. Now the height has to hit the base at 90 degrees, which this 10 centimeters does. And it's easy to get it mixed up with a slanted height, which goes up the side of the cone. So we're going to do a third times pi times the radius, which is 5 squared, times the height. And I'm just going to get my calculator. And the way I do this is pi times 5 squared times 10, press equals, and then divide it by 3. And that's the same as timesing it by a third. You get the same answer either way. 261.79938, blah blah blah. Now, to 2 decimal places, this is going to be quite an interesting one, because it's going to be 261 point, and that 9 is going to move that 9 up to a 10, which will make that kind of 80 centimeters cubed. Okay, so to do this question, I'm going to start off with a number line, and I'm going to put the number given to us in the question in the middle, so 89.6. Now it says it's the nearest tenth of a second, so what I want to do on the left hand side is put the next number down. So what could it have rounded to if it was slightly less? Well, the next one down would have been 89.5, and the next one up on the other side would have been 89.7. Now to find the bounds, we just find the halfway points, and this left hand one will be the lower bound, the right hand one will be the upper bound. So that's going to be 89.55 and 89.65. Now it says it wants it as an error interval and use t for the time. So we put t in the middle, then we put the greater than sign on the left hand side, and then just the normal inequality on the right hand side. Now these two signs here will always be the same. Okay, so when you're asked to do an error interval, it's that way around. So we're going to do our 89.55 on the left hand side and 89.65 on the right hand side. Now the reason why the inequality has an equals underneath it on the left hand side is it can be 89.55 and still round to 89.6. The reason it doesn't have one on the right hand side is 89.65 would have rounded to 89.7. So if you just remember, the things in the blue circles are always that way, and the letter it asks you for, just put in the middle. If it doesn't ask you for a letter, you can just pick any letter you want. You can call it X or something. And then the lower bound is on the left hand side and the upper bound is on the right hand side, and the lower bound's always here and the upper bound's always here. This question asks us to factorise, which means put it into brackets. It's a quadratic because it has an x squared, an x and a number term. Now to do these, we first of all put 2 sets of brackets down if it's a quadratic. There's no number, well there is, it's 1, but there's no visible number before the x squared, so the first 2 things in the brackets is going to be x and x. Now to do this question, we need to think of 2 numbers that add together to make the 12 there, and times together to make the minus 45 there. So to do this, to find what those 2 numbers are, I'm going to find the factors of minus 45. So I could try 1 and 45, so let's have a think. I could have a positive 1 and a negative 45, that would make minus 44, or I could have a negative 1 and a positive 45, that would add together to make 44. Now we needed to get to that 12, so that's not going to get 12. So 2 doesn't work, there aren't any with 2. 3 and 15, let's have a think. Positive 3 and negative 15 would be minus 12, so if we have a positive 15 and a negative 3, that would add together to make the 12. So we'll have a negative 3 and a positive 15. And you can expand that to check that it works. And it doesn't matter which way around you put them. So I'm going to put my answer the other way around, like that. Now this question can seem a bit daunting because it's talking about bearings and yet it doesn't give us a single angle. But whenever you are given a question on bearings and there's not an angle, then really you should be thinking, is this trigonometry? Now trigonometry is grade 5, so it's the hardest on the foundation paper and actually quite difficult on the higher paper as well. So let's have a look at how we use trigonometry with bearings. First thing to notice is what we're asked for in the question, where it says work out the bearing of Freetown from Gamley. So we are at Gamley and we're working out the bearing of Freetown. So we're going clockwise from north, so we're working out this angle here. Now, we can't work out any of those angles on the right hand side really, but we can work out this angle here is 90 degrees, and the reason we know that is because it says the hiker walks west, and the angle between north and west is 90 degrees. So we know we've got 90 there, and if we knew this one here, then we could add it to 90 degrees and take it away from 360 to work out the green bearing. So it's this red angle that we're looking for, which I'm going to call x. So we go use trigonometry. So first step with trig is to label the sides. Well, the marked angle is the x, so the opposite here, and we've got the adjacent here, because we've got the 90 degrees here, because the angle between west and south is 90 degrees, and we've got the hypotenuse here, which we don't need. Then I do my SOHCAHTOA, and it's obviously going to be TOA that we're going to use. So we draw our TOA triangle. So tan, the angle, which is x, equals, and then we've got the opposite, which is 50, over the adjacent, which is 65. Now whenever you've got tan x equals, what we need to do is we need to inverse tan both sides. Let's make sure I put my lines in. Inverse tan both sides, and so we get x equals inverse tan of 50 over 65. And we've got loads of videos on trigonometry, so if you're watching this not really understanding what we're doing, then maybe have a look at some of those videos. I'm going to type that into my calculator, and it says x equals 37.568 blah blah blah. Okay, so we're going to add that to the 90 degrees, and we're going to take it away from 360, so we'll write that down. So 360 take away the 90 plus 37.5685 blah blah blah. Okay, so I'm going to type in 360 minus brackets 90 plus answer, close brackets, and it gives me the answer of 232.431 blah blah blah, and I'm going to just write that down as it says to near this whole number, so it's going to be 232 degrees as my bearing. And the last thing is just check that that makes sense. Well, I know 180 degrees will be here, so it's more than 180 degrees, and I know this one here would be 270. So we're looking for an answer between 180 and 270, so we know that's probably going to be correct. I hope you enjoyed that video. Don't forget you can go to our website onmaths.com, which the link will come up there now, and to do the paper online, or to check out our other stuff. We've got topic busters for all of the topics that can come up. Don't forget that this is only a practice paper. We call it a prediction because what we've done is we've cut out the stuff that we feel has come up in paper 1 and 2, and so leaving a few topics that we select which ones the exam board generally goes for in paper 3 on the calculator or paper. So it's only a bit of practice. Please don't rely fully on this paper at all, and just make sure you do normal revision as well as this video. If you've liked this video, please click like. If you really like it and want to see more from us, especially in the next few days, please click subscribe. Thank you very much.